Hello, my name is Corwin Stout, and in this video I will be discussing my design and implementation of the My Vacation program that I wrote to fulfill the requirements of the term project assigned to our class, Software Architecture and Design Patterns at the University of Michigan in Dearborn. We were tasked in this project to create a vacation flight planner with an easy-to-use GUI, departure date of February 29th of 2020, and an arrival date between March 1st and March 14th of 2020. We had to have 5 departure cities available, and then at least 2 cities from each US state and 1 for each other country's capital as possible arrival locations. The return flights um, should be arranged by cost from the searches, and we should perform a local database search first and then reconcile that data with current data from the web. Some other things we had to keep in mind were that our design had to use at least 3 different design patterns that we learned about in this class, and we should populate the returned results with from the local database first, because that'll take about a second, versus then reconciling that data later using a web search, which can take up to about a minute. For the overarching structure of my program, I chose to use the command pattern. Search commands are set to be executed by a local handler and a remote handler. These search commands contain the flight search information. The local handler gets results from the local database, and the remote handler gets results from the web. Off to the right, up top, we see the generic pattern, and then below that we see my modified pattern for this program. And so we see that the command class maps to the search command, the concrete command maps to the flight search command. Instead of a receiver, we have a local handler and a remote handler that both inherit from a more generic handler class. For a client, I have the GUI that I've created and an invoker, which I didn't rename, but my invoker, when it gets a local search command set to it and executed, it just executes in line with the rest of the program. But when I get a remote handler executing a command, I assign that to a thread and have that run separately so that the GUI doesn't lock up waiting for that web result to complete. For my search command, I used a decorator pattern. So for every piece of search information like departure city, arrival country, or whatever, there is a decorator class to add that information specifically. Also, by design, only one arrival location decorator will be applied to a given search command, so only an arrival city or an arrival country will be applied to any given search command. So in the upper right, again, we see the generic pattern from our textbook, and then below that we see my modified decorator pattern. And so originally what was the component is now the search command that we saw in the previous slide. The concrete component is the flight search command, but now we see the decorators here. So the decorator is now the search commands decorator, and then I have this set of concrete decorators. So we have the departure city and the departure date decorators, and then arrival date decorator, and then an arrival city, arrival state, arrival country, and arrival continent are all available decorators as well. For the handler component, I use the chain of responsibility pattern. So the handlers contain the actual searching functionality, and there are 2 independent chains, one for local searches and one for remote searches. So if a search command contains information for an arrival country, for instance, then the local handler for arrival cities will pass on the search command to its successor, which is the arrival state handler, and then that will pass on to the country, which will actually end up handling the the search command. And so in the upper right, we see the original generic class diagram for a chain of responsibility pattern, and then below that we see my modified version. So for each local handler and then for remote handler, each of them has its own individual chain for the responsibility. For my database and web interface classes, I chose to apply the singleton design pattern. I did this because we only ever want one connection instance to the local database so that different operations can't mess with the same data at the same time. And we only ever want one web browser running in the background because we don't really need more, and that would just slow the program down. I used a somewhat Python-specific implementation to preserve the spirit of the singleton pattern, despite there being no true private and protected class members in Python. So you can create multiple instances of the database class, but each one is going to have the same instance of the underscore database class that we see here. So in the upper right, we see the original generic singleton pattern, not much to see. And then below that, we see the two um, singleton classes that I use, the database class and the web interface class. And here we see the whole class diagram. In the kind of upper portion, we see the general shape of the command design pattern. And then beneath each of those, we see the decorator pattern applied to the search command part of the command pattern, and we see the chain of responsibility related classes applied to the the local and remote handlers. And then we see that the client and the local and remote handlers all have access to the singleton, or to the database class, and the remote handler has access to the web interface class. My local database schema consists of two tables, one for flight information and one for airport information. My flight table consists of fields for the ID of a flight, which is just an auto-incrementing integer that is unique to each entry. The departure airport and the departure date and time, the arrival airport, arrival date, and arrival time, the cost of the flight, the airline of the flight, the total duration, and the number of stops. My airport table contains fields for the name of the airport, the code, which is the three-letter code that's unique to every airport, and then where it's located, so the city, country, and continent, and the state if it's within the US, and an optional search term. I found that Expedia doesn't, which is the website I use, doesn't always handle the three-letter codes as you'd expect. So I found that for some airports it was useful to have a search term to search instead. The airport table I populated manually. I created a list of all of the states and all the countries, and searched for one or two major airports in each. The flight table, which has a lot of entries, I populated using a Python-based web scraping script. This is the graphical user interface that I came up with using the Python library tkinter. Here we have 5 different drop-down menus. The first one is choosing between 5 different departure cities. Then the next one has an option for departure date, and while there's only one available departure date, I still created a drop-down menu for it for consistency. And then there are 4 different arrival location categories. You can search by city, state, country, and continent. And when you select one of them, then the next drop-down menu changes accordingly, which has a list of all of the available locations within a certain category. And then an arrival date, which lists the 14 options between March 1st and March 14th. Now I'll do a demonstration of my program. I just launched it. And in the upper left-hand corner, we have the departure cities that I programmed. These are the 5 cities that I chose to get search information from. And then we have the drop-down menu for departure flight. I only have the one option, but I'll click it. And then we have the arrival categories: city, country, continent, and state. So here are all the cities that are in the local database. But if I change the drop-down menu to country, then these are all of the countries in the database. And I can select the continent, and it'll show the available continents, and then the US states. These are the letter abbreviations for the states. But I'll go back to city for now, and I will think of a fun city to fly to. Um, let's go to Madrid, and then we will leave on or arrive on the 6th. And before going further, I will place an order just right now. And of course, no flight is selected, so there's an error message saying that. So I'll go back and click search. And here we see almost immediately there's flight information from the local database that is populating this right here. And in the lower left-hand corner, we'll see a progress bar start to progress. That represents the progress of a background web search that is going and reconciling this data. So how that works is if the flight information that it finds is clearly the same flight and that it has the same arrival and departure information, but the cost is different, it'll update that cost. But if it's a new flight altogether, as long as the airport information is in the database, then it'll add it as a new flight entry. For demonstration purposes, I have new flight information being printed to the terminal. So at some point here, we should start to see new information coming in. And there it is. So we see a couple of flights being updated and a couple of new flights that are being added. And I saw early on that there were a couple of pretty cheap flights that aren't in my local database. So now if I go back and click search, the local results will show, and I'll show these cheaper flights here, and I can now place an order, and we'll see this more detailed information, and I've placed an order. And that concludes my presentation. Here are some references that I used in the while working through this term project. Thanks so much for watching.